age-old problem the old iron heads have had for a long time. That's called wet sumping. Lapping the old seats doesn't work. It only widens the seat out, so you have many failures. Compound like clover can leave the finish larger than the oil molecule and can also lead to failures. Beating the ball doesn't really work either. The metal has to go somewhere, usually up the seat, and interferes with the ball alignment or downward bulbing the opening. Observing spring action, I find that the spring sometimes is not square to the ball and could induce side loading at times. The best success that I've had is by using a Teflon ball where the spring is captured. The ball cannot turn, so therefore the ball wears to the seat very quickly instead of inducing wear all the way around the ball. This is a second installment from my first one using the Teflon ball and seat and spring to a conversion to the K-style. I want to thank Dr. Dick for supplying this JPEG on the forum. I do not have the original setup or the pump body to tell how it was actually set up, but under today's conditions here, this is the style Harley uses now, where the ball contacts the tangent or a 45-degree angle. And I'm going to assume the older style, which required more precise machining, the contact was actually made in the zone where the through hole comes through. The machining tolerances for this has to be pretty tight. It still has the 45 degrees. This style here seals extremely well under low pressures. More than likely this stem shaft was installed on here to make sure that this ball would stay square or seat into this style. But we can convert to that style. I don't know if it'll help, but this is the original adapter out of the 74 Harley, and as you can see from here, the total length of that thing is going to be 1.566. The hole from the top to the bottom of there is 0.566. This spring extension is 3.340, and this distance between here and here is 0.750. Now, looking at the pump body with the check ball installed, the height between the top of the check ball and the top of the pump body is going to be 1.120. Now, when this thing is installed in here, the way I've calculated it out, this bottom of this to the top of this, you're going to have 0.370 ball travel clearance. But in order to achieve that, we've got to drill a 0.125 hole in the end of this spring extension, 0.625 deep. Now, this will allow this shaft to travel 0.345. Now, the ball shaft is going to look like this. Although this is a tool, which I'll explain later on, the ball will look similar to that. Now, the original Harley ball was mild steel, easily drill a machine, but ball bearings are hardened. So in order to install a 1/8 shaft in this ball, you first have to grind a flat spot on one side of the ball. Once you grind a flat spot on the side of that ball, you take off the surface hardening, and you can usually drill that ball and tap it to install a 1/8 shaft. Now, what I usually do to ensure you don't have any pressure build up or vacuum build up while this shaft travels in and out, I would drill a little small hole angled from here to the back of the hole which you're going to drill. This will equalize the pressures, so when this shaft moves in and out, the oil can freely flow and the spring can freely move. In this installment, I'm going to make a plug seat for the old iron head oil pump. In this first installment, This is a 3/8/16 bolt. The first thing you need to do is turn the head of this bolt down to a diameter of 0.421, roundabouts in that area. You do have a little fudge factor in there. After you get that turned down, you would center drill this with a number 4 center drill. Then when you get through with the number 4 center drill, you come back and you would knock that hole out with the number 4 with this number 5. And on that you would go down to the depth of about almost to the very edge of the cutting flute. Now these are 60-degree centering drills. I don't have a set of 90 degrees, but that would be the preferable way. I'm going to have to buy some, because the 90 degree will give me a 45-degree cut, which is more along the stock. It'll give me a narrower seat band. But either way, this little cup, the length of it does not matter. You can cut this off at a later time. Now, after you get all of this center drilled out, you do that first. Then you would drill the rest of that bolt out with a number 1 drill. That'll give you close to a 5/16 oil hole, which is plenty enough to oil that iron head. Okay, on this installment, we got to prepare the pump body. Fortunately for us, Harley-Davidson made the hole coming through this body 3/8. Now, the tap hole for that thing is 5/16, which is perfect for the 3/8/16 tap. What you want to do, it doesn't matter how far that you tap down into that hole, because it really doesn't matter, but you do want to go far enough that you can seat this cup all the way down. Once that is done, just clean up your work. Now, this can actually be done on the bike. All you got to do it on the bike is to remove your adapter, let all the oil run through the pump, because it's free flow. After it runs through the pump, then you can take your tap. After you pull the ball out, you can run that tap through there. And in order to capture the cuttings, you would use grease on the cutter, on the tap, but also you could put a little bit of solvent in the oil tank. And as the solvent filters through the system, it'll go through the hose, through the pump, out through the adapter. No oil or anything is going to come up through the discharge opening in this body, which goes to the engine. This is up. So all your cuttings and everything is going to flow out. So this can actually be done on the bike. Okay, on this operation, you take the cup that's been cut with the center drill. You screw that into a 3/8/16 nut. And put that inside your vise. Now, you can use ball bearings and lapping compound, but it takes a long time to do it, and you got to go from coarse to fine to fine to fine until you get it perfectly done. If you run the center mill without any chatter, it cuts a pretty clean hole. Now, what I have bought from Precision Balls, these are diamond infused laps. You can get them in various sizes, various grades. You put a little fine machine oil in there, and then you can lap this in to what you need. Now, when you're lapping it, you use back and forth motion, and also you rotate the ball, because you want this thing to make a nice polished seat. Now, that would be this for this operation. In this segment, what we're going to do, we're going to check our work to see if this ball is going to seat. First thing I do is put my finger over the seat. I pull a vacuum on the seat. and I check the assembly to make sure I'm not losing any vacuum through any of the hoses, because you notice I'm using clamps. That's hillbilly, but that's the way it goes. Alright, after I'm sure I have no leaks in the system, what I'll do, I'll take the ball and I'll put the ball on top of the hose and the cup. I'll pull another vacuum on. Alright. Once I get the vacuum pulled, I'm going to close off my valve. Turn off my pump. And just sit there and watch it. What you're wanting to see is that this ball is seating. Because if it's seating with the little spring pressure you got behind it, it's going to hold. And hopefully that'll cure your wet sumping. I have two more designs that I'm working on. It's called a wafer and the other one's called a cartridge. The wafer is internal and the cartridge can be installed from the external, but I don't have the tooling. Some of the threading that's used on these old Harleys are old school automotive stuff, and it's hard to find that stuff. Matter of fact, some of the tooling I couldn't find from a machine shop, so I had to go Chinese. Apparently they're still using some of them old 24 thread systems over there. But make sure that it holds.